Okay, welcome back. We are doing the Hydrate practice problems. And as always, show all your work in order to receive full credit for the following problems. Now, I will be underlining what we're given and boxing what I'm looking for. Just a good habit to have. All right, so I'm going to start off with question number 1, and then I'll do question number 8 at the end. All right, question number 1 says, a 15.6 gram sample of a hydrate, magnesium carbonate pentahydrate, MgCO3, and again, dot 5H2O means it is a hydrate with pentahydrate, okay, 5 waters, was heated to drive off the water. The mass was reduced to 7.58 grams. So after heating it, the mass reduced to 7.58 grams. All right, so what we're going to do is determine the percent composition of the anhydrous salt, meaning the salt without the water, and the water that was driven off. So I'm going to start off with writing down what the mass of my hydrate was. So my hydrate had a mass of 15.67 grams. After all the water was driven off, after it was heated, and the water was driven off, so I'm going to say after heating, or after heat, it came down to 7.58 grams. Now I do need the water because I need the percent composition of the water that was driven off. So I'm going to put H2O and show you how we get that. So in order for us to figure out how much water was in this compound, we're going to get the mass of the hydrate first minus the mass of the after the heating. And that's going to give us the mass of our water. So if you put that in your calculator real quick, should come out to 8.09 grams. Okay, so we have 8.909 grams of water that was actually driven off after heating. All right, so let's start off with our percent composition. So I'm going to start off with the anhydrous salt, which was after the heating. Remember, anhydrous means compound without water. So after it was heated, the driven off the water, so that means this is the anhydrous. And I'm going to write anhydrous. If you want, you can actually write the compound itself, MgCO3. But I write it out as anhydrous to remind myself to use this number. So our mass, because this is part divided by whole, the part of the anhydrous was 7.58 divided by the total, or the whole, which was the hydrate itself, 15.67, and it's going to be times 100 equals. So go ahead and get your handy dandy calculator out and calculate this out. Okay, so you should have gotten on your calculator somewhere around 48.373%. And I'm going to label this. You can say anhydrous, but like I said before, you can put the compound. And this will be your answer for this one. So that's for the anhydrous salt. I have to do my water next. So let's write down water. 8.09 was the part that was water, divided by, and again, just like we did in the anhydrase, we need to use the total amount of the hydrate itself, the whole crystal with water. So divide that by 15.67. Say times 100 equals. So plug that into your calculator. Right, and you should have gotten a 51.627% water. There you go. Okay, the main thing, like I said, when you're doing percent composition, always remember percent composition is part divided by whole times 100. Okay, that's the main thing to remember. Okay, so let's say, hey, you know what? They gave us a chart, so I'm going to do one with a chart. That's number 8. They gave us a chart. Perfect. But we're still reading it. So we're going to start off with 7.462 gram sample of sodium carbonate decahydrate. Oh my goodness. Was heated to remove the water. The mass of the anhydrous, or after heating, that remained was 2.764 grams. It says, what was the percent composition? And in this case, it just wants water. Beautiful. Well, obviously we need to know the mass of the water that was driven off. So again, before heating minus the after heating. So you can put a minus sign here. And that gives you what? So put that in your calculator. Correct. Comes out to 4.698 grams. And the beauty to this is we only have to do one. So percent composition. And in this case, it's going to be of water only. So get the part that's water, 4.698. Divided by the total, which was the before heating, that's the mass of the hydrate. And notice that they plugged it in for you. All right, 7.462. Then we're going to say times 100 equals. So plug it into your calculator real quick and see if we get the same answer. Okay, so it should come out to 62.959% water. So basically, be on the lookout of what percent composition they want. Do they just want the water itself, or do they want both the anhydrous sample salt and the water? So that's why I'm saying box what you're looking for, because maybe it's just something short and sweet and you just have to do one. All right, until next time.